next lesson is called Rules of Exponents. Now these three vocabulary words are repeats. We've had them before. The first time we saw exponents was in the very first lesson of the very first chapter. But what we're going to do is learn about powers and exponents a little bit more deeply and learn how to use them. Let's go over our vocabulary terms. First is a power. The power is a number that has an exponent with it. That whole piece is called the power. And what it means is that it's the result of repeated multiplication of the same factor. So when we see exponents, we are talking about multiplication. And there are two parts to a power. The base, which in a power is the factor that is multiplied repeatedly. It could be a number or it could be a variable. And the exponent is that tiny little number that hangs in the same area that you would put an apostrophe in language arts. So the exponent is the number that tells how many times the base is used as a factor. So as I've explained to you in previous lessons, whenever you see a power, as I even just said before, we are multiplying. So a power is a representation of a multiplication expression. The one number that gets multiplied, that is every single factor, is the base number. And the exponent tells us how many times that factor gets multiplied by itself. Let's start working on the first of our 5 examples. Take a look at this number 1. Find the product. Write your answer using exponents. Product. So here we're basically using multiplying twice. We're using exponents, which is multiplication, and we're going to multiply. Now it's important for you to realize that the only way that these can be combined is if the base numbers are the same. And here the bases are the same, they're both m. So I want to do an expanded form of this to show you exactly what we mean. I don't want to just give you the trick and say that that's it. I want for you to understand why the trick is the trick. So m to the 4th power times m to the 5th. Let's expand this. M to the 4th means the base m times itself 4 times. So there's m times m times m times m. And that is being multiplied by m to the 5th. So m to, you know what, I have to write these a little bit smaller, otherwise we won't fit them. Sorry about that. So we'll start again. M to the 4th is m times itself 4 times. And this is being multiplied by m to the 5th power, which in expanded form is m times m times m times m times m. So what do we have here? We have m, and how many times is m being multiplied? 1, 2, 3, 4, 5, 6, 7, 8, 9. So m to the 4th power times m to the power of 5 equals m to the power of 9. So now it's time for the trick, or the rule. The rule is that when you are multiplying powers, and when the bases are the same, then the base stays and you add the exponents. So here we have m to the 4th times m to the 5th. 4 plus 5 is 9. So the product is m to the 9th power. Now we're going to divide. Find the quotient, write your answer using exponents. And we're going to do it the same as we did the multiplication problem, meaning we're going to write the expanded form of the numerator and then the denominator. So we're going to need a very long fraction bar. Let's start with expanding our numerator. 12 to the 8th power means 12 being multiplied 8 times. And then 12 to the third means 12 being multiplied 3 times. And now we're going to treat this the way we would any other problem in which we can simplify, cancel numbers out, or when we multiply. So in other words, this 12 and this 12 can each go into each other once. Likewise, these two 12s cancel each other out. And these two 12s simplify. So what does that leave us with? Well, it leaves us with a 1 times 1 times 1 in our numerator, in our denominator. And you know that anything over the denominator 1 equals itself. And what about our numerator? We have 12 times 12 times 12 times 12 times 12, which in a more simplified way means 12 to the 5th power. 12 to the 5th power divided by 1 is 12 to the 5th power. Here's the expanded form of this problem. And the quicker rule is that when you are dividing powers, as long as the bases are the same, what you do is you subtract the exponents, numerator minus denominator. 8 minus 3, which gives us 5. So 12 to the power of 8 divided by 12 cubed gives us a quotient of 12 to the 5th power. Okay, so now what we're going to do is we are going to use monomials in multiplying and dividing. We have one of each type of problem here. You'll see the direction simplify. We can't evaluate because we don't know the value of the x, so we can't get any further than ending with a variable term. Now, it's important for you to understand and to realize that this exponent 3 belongs only to the base. It belongs only to the number or the variable to which it is attached or from which it's hanging. Likewise, this 2 belongs to the x. It's the x that's being squared, not the coefficient 5. Neither is the coefficient -4. Does that have anything to do with the exponent? The exponent here belongs with the x's. So what we do when we are multiplying monomials that have powers is it's 2 steps. First, we multiply the coefficients. -4 times a +5 is -20. Next, we multiply our variable terms. We have an x to the 3rd times x to the 2nd. So we write down our x, and you know from our first example that when we are multiplying powers, we add our exponents, so it's 3 plus 2, which makes it x to the 5th power. So -4x to the 3rd power times 5x squared equals -20x to the 5th power. Now let's do some division. The rules are going to be the same. We'll take care of the exponents, we'll take care of the coefficients first, then we will deal with the powers, in this case, a variable term. So we're going to take these coefficients separately. Let's take a look. We're going to separate them from their variable terms, from the variable piece. So what we have here is a -9 over a -15. Now what we're going to do is simplify that fraction. With the numbers, a -9 over -15, we know our answer will be positive because when we're dividing two negative numbers, our quotient is positive. The number -9 and 15 both have a 3 as a factor. 3 goes into 9 3 times. It goes into 15 5 times. So we have our coefficients simplified. Now we have to take care of the variable terms that have the exponents. N to the 6th power divided by n, which I like, especially for beginners, to write in the exponent 1. Even though it's assumed, it's understood that it's there, when we are using those exponents, it's good to remind us that it's there. Sometimes students will see that there's nothing there and treat it as if it's a 0. Just like when you have 1x, it's good to write in the 1 instead of just leaving it as an x. So since our variable is an n, we'll put the n right here. N to the 6th divided by n to the 1st. Remember the rule from our second example. When you're dividing powers, you subtract the exponents. 6 minus 1, that gives us 5. So negative 9 n to the 6th power divided by negative 15 n to the 1st is simplified to 3 n to the 5th over 5. And so now what we have here is a multi-step problem. Every piece, every step to this division problem, we've already learned how to do in the first 3 examples. All we're doing is combining them. We have a numerator and a denominator. We see our numerator has an expression in it, so we need to simplify that expression first. We have 6a to the 4th power times a negative 4a to the 3rd power. So just as we did before, we are going to take our coefficients, our 6 and our negative 4, and we're going to multiply those first. 6 times negative 4 give us negative 24. Now we have to multiply our powers. We have a to the 4th power times a to the 3rd power. So I'll write my base a, and I remember that when we are multiplying powers, we add the exponents together. 4 plus 3 is 7. So our numerator is now much simpler, much friendlier. Negative 24a to the 7th power. And then what we'll do, since the denominator is already simplified, we'll just move it over into our new fraction. 3a to the 6th. Now, 2 things tell me that this fraction is not in its simplest form. The fact that the coefficients can be simplified, so that if this negative 24 over 3 was a fraction in isolation, it would not be simplest form. That's one way to look at it. Also, I see the same base, each with its own exponent. That piece can be simplified as well. So we're going to move to the next line. We are going to take this piece first, the coefficients. So as I said, when we're simplifying fractions that have monomials in them, once we've done any multiplying or dividing that is asked of us, we have to treat the coefficient as if they were a fraction in isolation. So negative 24 divided by a positive 3, right away I know it's negative. Negative 24 divided by 3 is negative 8. So we've lost the number piece of our denominator, and that's okay. Now what we have to take care of is our variable terms, because those have the powers. We have a to the 7th divided by a to the 6th. I'm going to write my variable, and then remember when we are dividing dividing powers, we take our exponents and we subtract them, numerator minus denominator. 7 minus 6 is 1. So the simplified version of this fraction is negative 8a to the 1st power. And we have only one more example before we're done for today. And we haven't seen one of these problems in probably a few weeks. An area problem, as I told you at the beginning of the year, we'll see a lot of area and perimeter problems in pre-algebra. And again, we're just going to take the skills that we have been learning and apply them to this situation. So to find the area, whenever I see this word area, my go-to is the formula. And the formula for finding the area of a rectangle is length times width. Now what we do is we substitute what we're given, our values for the length and the width. Our length is 5x times 2x squared. And we simplify. Remember, we multiply our coefficients first. 5 times 2 is 10. I'm going to insert a 1 here as an exponent. X to the first power times x to the second power is x to the third power, because you remember that when we are multiplying powers, we add the exponents. So our area is 10x to the third power square units. Not too challenging.